So let's get on to 1C, types of functions and implied domain. So we've talked about what a function is. And we said to see if something is a function, we do the vertical line test. To see if it is a one-to-one function, it also has to pass the horizontal line test. So if you get confused, I remember that function is vertical and the horizontal line, if I think one-to-one, I might write that as one-to-one. That looks a bit like an H, does it? So we do the horizontal line test. So what does it mean? For a one-to-one function, we say that different X values map to different Y values. And that's the other way around to last time. We said if it's a function, it's different Y values map to different X values. So it's the other way around. Is the function one-to-one? So we do horizontal line test, one-to-one line test. So if we have something like a parabola, he's getting good work out the parabolas. So it looks like this. If we do a horizontal line test across here, we know it's a function because of the vertical line test. Is it one-to-one? No, not one-to-one, because it passes through twice. Because for the X value, say at -2, they both go to 4. So not one-to-one. What about if we had something like a square root X graph? Is this one-to-one? Does it pass the horizontal line test? Yes, is one-to-one. So that a function that is not one-to-one is, we call that many-to-one. So you need to ask yourself 2 things to see if it's a one-to-one function. You go, 1, is it a function? And if it is, you can then ask yourself, is it one-to-one? So 2 things, is it a function? Is it one-to-one? All right, so let's have a look at this set of points. Is it one-to-one? Does every X value map to a different Y value? Well, yes, it does. So this is one-to-one. But if we look here, we've got the 4s there. So every X value, some of them, we've got 2 values that map to 4. So this one, no, not one-to-one. Parabola, we talked about that. Is it one-to-one? No. 2x plus 1, it's just a straight line that goes through 1. It looks something like that. Is it one-to-one? Yes. And something like f of x equals 5, that's a bit weird, isn't it? It's like y equals 5. So it would be there. So if I did a horizontal line test, I could do one that touches every point. So with this one, we say no, not one-to-one. Okay, so let's have a look at implied domain. So what does that mean? The first one's probably not a great example, but this second one's a good one. Because I think what happened there if x equals 2? And if x equals 2, you'd get a denominator of 2 minus 2, which is 0. So that one would have to have a restricted domain. So let's have a look at A. With something like 2x minus 3, the domain can be all the values, so we say R, and the range can be all the values R. It's just a boring old straight line. But for B, let's think about what does it look like. Well, it's a truncus because it's a 1 over x squared, but it's been moved 2 in the positive direction. So it looks a bit like this. Looks a lot like, actually it does look like that. Let's do this one. So what is its implied domain? The domain is all the numbers except for 2, because we have an asymptote here at x equals 2. And what's the range? Well, we've only got the positive numbers and we don't include 0, so I could write that lots of different ways, but I'll just do R plus. And let's have a look last of all at C. It's a square root x graph which looks like that. And it's been moved 6 units inside an opposite negative direction. So the graph looks like this, and it goes through. So we think, what is its domain? Well, the x values go from -6 included to infinity. What is the range? All the y values, we start at 0, and it will also go to infinity. So they are called implied domains, because you just have to figure out which numbers will be on that graph or which numbers you can use.